and welcome everyone to EDA Summit 2024. Thank you so much for joining us today. We've got a really insightful session in store for you. Today we're going to be exploring how to securely manage asynchronous APIs and event brokers for unified streaming. I am Buddha, developer advocate at Tyke and the board chair of the Open API Initiative. Joining me in today's endeavor is Sandeep, who is our lead solution architect here at Tyke. Now, just to give you an idea about the agenda, we're going to be starting off exploring the world of EDA and the state of EDAs and its adoption. To begin with, some of the challenges that is being posed to developers and adopters of EDAs today. We'll talk about API management in the world of event-driven APIs or event-driven architectures. And then we'll look at very specific use cases, three very specific use cases which pose a challenge when it comes to working with EDAs at an enterprise level. And then finally, we'll end our session with a demo showcasing some of those elements from the use cases that we will discuss. So hopefully that gets you excited to hear more about securely managing asynchronous APIs over the next 25 minutes, hopefully. So now thinking about the world of APIs, there are usually two categories that you come across. There is the more familiar synchronous APIs, the world of REST, your SOAPs and GraphQLs of the world, fairly popular at this point of time. Most organizations have adopted some variation of that already. And then there is the asynchronous world, different paradigm, which looks at more real-time interactions and how to make that possible through a publisher subscription model. So while this is relatively new compared to the synchronous world, the popularity of asynchronous APIs and event-driven architecture has been growing. And that is reflected in some numbers that I'm going to be sharing with you here, starting with 72%. So event-driven architecture is widely being used for 72% of global businesses today, even though it's at a different level of maturity, but this is already something that people are exploring at an enterprise level. And then of those who are already in the process of implementing EDAs, 94% would consider applying it to use cases, other use cases, or expanding their use cases in their organization. So needless to say, this is a popular and ever-growing area that we'll see even more of in the years to come. To give you a bit of an overview of what event-driven APIs are all about, they enable real-time notification of changes to data and application state. They provide an efficient way to propagate information to multiple parties. They help synchronize data changes across multiple applications and data stores. And what that translates into are some of the key benefits of adopting EDAs, which is starting off with operational efficiency that gets a lot more, it becomes a lot higher, things get a lot more efficient from an operational standpoint. You've got enhanced customer experience, and you've got a much greater, easier, and more exciting pathway to innovation, where the interactions are now real-time. Interactions and outputs and outcomes are a lot more real-time than what you would hope to achieve with synchronous APIs as well. So with those benefits in mind, let's look at some of the challenges, because again, not just like any other technology, EDAs are not a perfect solution. There are always going to be challenges especially in the early days of its adoption. And again, the numbers seem to support some of those possible challenges or highlight some of those challenges, with 75% organizations citing the lack of adequate technology today to implement event-driven architectures effectively, and that becomes a roadblock for adoption. Then you've got tooling challenges, with 59% of organizations believing that they haven't yet identified the right tooling or vendors to meet their needs. And what that then translates into is that only 13% of organizations have reached the gold standard of EDA maturity, which has been applied throughout the organization for most of the use cases. So just 13% at this point of time. Like I said, it's still early days to a point. You'll see these things growing and becoming better. And what that would need essentially would be three things. Now that's true across technologies. When you're thinking about the true adoption of a technology and how that pathway can become easier, the maturity of that adoption of that particular journey and how that could become easier, there are usually three things you tend to consider. Starting off with obviously the business value, the key drivers behind adoption. Why are you going into the world of event-driven architectures? What kind of value is it bringing? What kind of benefits can you achieve by virtue of doing so? And we've touched upon some of that already in the first section of this talk. The second part of this is usually standardization. How do we make it very easy for developers to adopt? Typically, having some sort of a standardized specification around it makes life a lot easier. It keeps things a lot more consistent and predictable. That's just another area. And maybe that's something that's already been explored in this EDA summit, and potentially something that we'll see more of in the years to come. And something like async APIs, for instance, is doing already. And then you've got your tooling ecosystem. The maturity of those tooling ecosystem essentially drives that adoption in a much more efficient way. To it, we're going to be talking a little bit about event native API management today. Because once again, so just to give you a bit of a background of Tyke, which is the company I work for. Tyke is a cloud native API management platform which is powered by an open source API gateway. We are pretty much agnostic to API protocols at this point of time, but we are very aware of the specific needs of those protocols, whether it's REST, GraphQL, gRPC, and in this case, asynchronous APIs. But anytime we think about developing or designing APIs, there's once again two parts to this. There's the business or the functional logic of your API that usually a lot of developers tend to enjoy and find more exciting. And then there is the operational side of things, which tends to include things like security and governance and observability and cataloging and versioning. All of those elements that essentially makes an API enterprise ready. Tends to be a little bit on the boring side, but it's essential. It is very much essential when you're developing or designing any kind of APIs. Now, that's true in the event native space as well. So with that in mind, we introduced Tyke Streams here at Tyke, which brought API management to the world of event-driven architectures by providing a comprehensive set of capabilities to secure, transform, monitor, and monetize your async APIs. We'll see this in action a little bit later, but again, it's not about Tyke Streams necessarily. That's why I'm not entirely focusing on that. But the idea here is tools like Tyke Streams essentially help or clear out the pathway or make the pathway a lot easier when it comes to adopting any kind of technology, in this case being EDAs. So what that API management in an asynchronous world would look like would include things like security management. Again, it's a no-brainer. It's applicable to any sort of API that you think about. Your authentication, authorization. Think about traffic management from a rate limiting and throttling standpoint, or even quotas in certain cases. Think about transformation and enrichment. And this can be specific to API protocols. In this case, we're talking about message transformation and content filtering. Think about how developers would discover your APIs. What kind of documentation can you provide? The developer portal being a great place to help developers get onboarded on your APIs. You've got event lifecycle management through versioning and deprecation policies, policy enforcement for compliance and governance standpoint, and then even all the way to event monetization, event API monetization, which will include things like subscription models and access plans and how you are managing all of that in a centralized mechanism in a distributed development world. So that gives you a bit of a sense of API management in an asynchronous world. What I want to touch upon next would include a few use cases. In this case, 3 very specific use cases. Some of them might sound very, very simple at the face of it. However, when you speak to developers at an enterprise level, these simple, small things tend to get exaggerated or exasperated when it comes to the scale of an enterprise. When you're thinking about millions and billions of transactions or API calls being made, these small things become building blocks. So if you don't get them right, things could go very, very wrong. If you get them right, it really creates that pathway for innovation, growth, and reduced complexity that is very, very desirable at an enterprise level and at that scale. So with that in mind, let's look at some of these use cases that I just spoke about. Starting off with something that's reasonably simple. Once again, looks very simple on the surface. A special purpose HTTP API endpoint to receive events and publish to an event broker. Now, the problem here is that reacting in real time to incoming events from external systems can be quite difficult, or in some cases, not even possible, because external systems typically are not capable of placing events directly on the message queues because they only generate HTTP events. webhooks, for instance. So what could a possible solution look like? Well, you could create dedicated microservices to handle each of the HTTP events and then on-queue the data for processing. But as you might already start to recognize, there is a degree of complexity that comes with it, a degree or rather lack of scalability that it might encourage to a point. There's a bit of development overhead that starts creeping in, especially when you start thinking of these things at scale. So what could a potentially better solution look like? In this case, again, I'm using the context of type streams, but any event native API management potentially might be able to address some of these solutions, and event natives tooling or platform might be able to help with something like this, where with type streams, you might be able to configure an endpoint directly that is capable of receiving HTTP events and forwarding them to a job queue or an event log. What that translates into is a simplified process of integration. By eliminating the need to develop custom microservices for handling HTTP events, you're reducing the overall complexity of the integration process itself. This also encourages real-time processing, directly forwarding HTTP events to a job queue or an event log enables real-time processing of incoming data without the latency introduced by additional microservices. And we already touched upon this also helps us reduce the overall development overhead, makes things a lot more scalable and therefore a little bit more cost efficient, which again, once again, at an enterprise level becomes very, very desirable. On to the second use case, we talk about securing and simplifying event broker interactions with API gateways. The problem here is that, well, if you're familiar with event-driven architectures, the event broker plays a crucial role in building real-time applications. Now, direct interaction with the broker usually requires specialized client libraries and underlying protocol that maybe the consumer application may lack and therefore cannot or is unable to interact with the broker. So what is a possible solution? Well, you could start off by maybe consider creating or using language-specific SDKs that encapsulate the complexities of broker protocol and provide developers with a more familiar and higher-level API for interacting with brokers. You could also consider creating or using wrapper libraries potentially. You could also consider creating custom client-side abstractions or custom middleware. Once again, as you might be hearing this, you might already be able to recognize some of the complexities that might start creeping into the picture as you start trying to customize things, especially once again when we start thinking about things at scale. So a possibly better solution here could be to configure type streams or a platform like type streams to stream messages from the broker using familiar protocols like HTTP or WebSockets or server-sent events, enabling faster and more accessible integration with various applications. When needed, mediate message formats so that consumer is not forced to develop custom processes, and that once again contributes to lowering the overall complexity of building or creating an event-driven API overall. Now, on to the final use case, which is about streaming events from multiple sources as a unified stream. So what's the problem here? Well, now the same type of events can be received from different sources, as you can imagine. For example, some will come from Kafka brokers, some will be posted through HTTP endpoints. Now, the internal system has to receive all of them using perhaps like sockets or server-sent events, regardless of where they may have originated. You were trying to have some sort of standardization here to make life a lot easier. Now, what is the possible solution? Well, you could consider custom aggregation services. You could consider consumer-side aggregations. You could also consider implementing transformation layer with middleware or an ESB. Now, anyone familiar with that world as well would know that there is, once again, a degree of complexity, and in this case specifically, a degree of higher cost that comes into the picture as you start considering solutions like ESBs. So now, what's a possible solution once again? Well, a better solution in this case could be to receive events from both sources and present them to the consumers as a unified stream of JSON events through WebSockets or server-sent events. Publish the stream access details to a developer portal and enable self-service for access for developers who are building out their applications. Once again, making discoverability as discovery of these APIs as easy as possible, abstracting away some of the complexities. What that does, or what that translates into, is that now you have a unified event stream. So with this aggregation that TypeStreams is enabling, events from multiple sources like Kafka brokers and HTTP endpoints can be presented as a single unified stream of JSON events, simplifying the data consumption process for internal systems. It also, like I said before, helps in protocol standardization. By delivering events through WebSockets or server-sent events, TypeStreams ensures that internal systems can receive all events consistently, regardless of their original source, without handling multiple protocols. Once again, goes back to reduced complexity, goes back to faster time to market, improved developer experience overall. Again, all of those things very desirable at scale at an enterprise level. So with that, hopefully I gave you a bit of an understanding of some of the typical use cases that tend to arise when you're working with EDA, some of the blockers around EDA adoption. What we want to go into next is a demo where I'm going to invite Sandeep to show you a little bit about how two developers who are trying to interact or build out an event-driven API or working within an event-driven architecture can use platforms or tools like TypeStreams to validate the inputs and potentially add a layer of security by virtue of doing so. So with that in mind, I'm going to let Sandeep do all the talking for the next 5 minutes. Take it away, Sandeep.
Now we'll look into a few configurations about TypeStreams within the Type dashboard. As you can see, we have few APIs which are already configured. I'll really focus on a couple of them. First, let's pick up stream spread bidirectional API. So in the bidirectional API, what we are doing is we have an input and an output. So input is basically a WebSocket event, and output is actually a Kafka broker running on a specific port. And then we have a pipeline, a processing that allows you to actually validate a specific input. So what we are going to do with this bidirectional input is basically we are going to do a WebSocket connection. So we will assume two different developers, a developer 1 and a developer 2, who is going to actually open up or send a WebSocket request as a specific user. So we will send out a WebSocket request as developer 1 and then other WebSocket request developer 2. And then what will happen is the processor in type, which is recognized or identified by the context variable here, which is which parameterized is $type context. And then beyond that, anything beyond this is basically considered as a user or an ID or anything that type can understand. So here, a developer 1 or developer 2 is we are going to use it or we are going to identify it as a user ID. So the WebSocket request to the input is going to be from two different developers. And then what we are going to do is we are going to send messages directly to the post endpoint here, which is basically this URL direct. And then we are going to do it on the event path. So that will allow us to see that we are able to send out requests or a WebSocket connection as a two different developers and then actually send message so that it displays in that event. So let's quickly test it out in the event here. So I'm going to just run the deployment. I have just a script which can do this. Okay, let me pick it up bidirectional. And I'm going to run a script 1. So it basically is connected now. And then I'm going to run script 2. Now it is done for developer 1. Okay, and now let's do 3. So now the developer 1 is basically sending a request And yes, there we go. It has sent out a request saying that I'm developer one, I'm sending a message, and you are able to see that because this is an open basically a WebSocket. The socket is open, and in the third script, I'm able to send as a developer one. I'm going to do another one, which in this case is going to be number 4. And here, developer 2 is sending a request. So when the developer 2 is sending a request, Tyke automatically understands it is developer 2 because it picks up from the actual context. And then it will only list out that where the socket is open from developer 2. So here the socket is open from developer 2 and it says developer 2, right? Because originally my socket is from developer 2. And when I'm running the last one, it says, okay, there is a request from developer 2. Now let me do one more thing. I'm going to just run this couple of times. I go back here. Obviously, I don't see it because it is not from developer 2. Here I should see 2 because it's from developer 1. And here I'm going to run this one again. So obviously, it will list out here as developer 2. So what this allows how Tyke can interpret a specific message using the Tyke context and then keep the input part open and also a broker with connects so that it listens to a specific message and goes out and shows that message in the output.
Thank you so much, Sandeep. That was really, really insightful. That's really good to understand a little bit about how sort of these validations could potentially work, and again, add that level of security in there as well. So thank you so much for that, Sandeep. Thank you so much everyone. Thanks so much everyone for joining this session as well. Hopefully you got a reasonably good understanding of the world of EDA adoption, some of the challenges associated with it, how those 3 specific use cases could come into the picture. In this section, this is your Q&A section. This is your opportunity to interact with us. Tell us if those use cases resonated with you, is something that you have faced. Have you figured out a solution around that? Have you considered alternative solutions, potentially some of the challenges with those solutions as well? Or if there are any other use cases that are currently top of mind for you, please tell us. We are here to answer your questions. But it's been a pleasure talking about all things EDA and securing asynchronous APIs through a new paradigm of API management that we can bring to the picture. So hopefully I'm looking forward to your questions, and for everything else, hopefully you enjoy the rest of the EDA Summit as well. Thank you so much.